I'm in SPSS and I have opened the ball dataset. This is from a student project where they dropped a number of different balls, golf balls, tennis balls, soccer balls, I think there's another couple, onto different surfaces, wood, carpet, concrete, from different heights, and then they looked at how high the first bounce was, the number of total bounces, and the time it took to come to rest. We're just going to look at one of these outcome variables, the time to rest, and we're going to have a look at a general linear model so we can look at each of these three predictor variables. So if we wanted to plot these, you could do some box plots for the ball type and the time to rest. We'll just do one quick one as an example. Better reset that. So we could look at the time to rest over the ball types. So it looks like the super balls are sort of bouncing longer, and we've got this really weird thing happening with the golf balls, and you'll see what that is in a bit. It's quite interesting. And between the time to rest and our covariate, the drop height, we could do a scatter plot. So time to rest and drop height, we could do a scatter plot. And we've got this really interesting pattern coming out where we've got some of them are up here and the rest are down here. Now if you do a little bit of investigation with this data, and I encourage you to do some more plots versus the looking at the ball types and the surface that they're bouncing on, what you'll find is that the golf balls bounce really high on concrete, but they don't bounce at all on the carpet, and we get this really funny effect here. Let's start off with a basic model, just adding these three things in, and then we can have a look at adding this interaction between the ball type and the surface in, and also there's another pattern which we'll see come out in the residuals when we look at that. So to build the general linear model with those three variables, I should clear this out, do it one at a time. So our response or dependent variable is time to rest. Our factors are the categorical variables, so that's ball type and bounce surface. Our covariate is our continuous variable, and that's drop height. Now our model, just to do the basic one, I'm just going to select all three of those and look at the main effects only. Continue, and we're going to save our predicted values and our standardized residuals. And you could also get your parameter estimates out if you want to. So we've got the null hypothesis for each variable is that there is no effect, or there's no difference. So no difference in ball types, no difference in the time to rest for the different ball types, no difference in the time to rest for the different bounce surfaces, no difference in the time to rest for the different drop heights. We've got very strong evidence against all of these, so we know that each of these does matter in the drop height, and we're explaining about 0.5 or 50% of the variation in the times based with these three variables. So that model is looking okay. If we wanted to actually write the equation down, we could do that with these beta values here. So we've looked at the model, we've got some significant results, and we know that each of these three variables does matter in predicting the time to rest. And the next question is, can we make the model better, or is there anything wrong with it? And we need to look at do some residual analysis for that. So the things we want to check for the residuals are that they are normal, that there are no outliers, that there is no increase or decrease in variance, and probably that there's no evidence of curvature or other patterns that we haven't included in our model. So the easiest thing to start with is to check for normality. You can do some more advanced analysis. I'm just going to do a histogram, or we're just going to eyeball it. So standardized residuals, and we'll put a normal curve on so we know what we're looking at, we're looking for. And because it's been standardized, we know that it should lie from -3 to +3. And it's not quite normal. So it sort of starts off okay, and then we have these outliers here, and it's sort of trailing off in a funny way. So that's not quite right. We might look and see if we can do anything to fix that a little bit. The next graph that we might want to look at is to check for if there's any patterns in the data or if there's any increase or decrease in variance. So I'm going to use a scatter plot. I'm going to put the predicted values down here, and for each predicted value we want to see what the error was, or the residual, and again we're just using the standardized residuals. And that's very interesting. So we can put a line on this across the 0 point. Just make sure that's 0. So what we're hoping to see is that they're randomly scattered, and from my point of view these do not look randomly scattered. There's a couple of things going on here. It's possible that there's an increase in variance. These values are all very consistent and then they spread out a bit, but more importantly, and it might be more clear if I change this y-axis, so we know that the standardized residuals should go from at least -3 to 3. So let me put the -3 in. Could even go further out. Hopefully, whichever way you plot these, you can see that it really looks like there's a curve in there. We do have these extreme values, and they came out in the histogram. So those extreme values there are showing up here. But it also looks like we have some kind of curved relationship. So the two things that we could look to do to improve this model, one is to add a curve in, and we can do that with a quadratic or a squared term, and you may or may not be comfortable with this depending on how much maths you've done, and if you're not comfortable with it then you don't need to look at that. You could comment on the fact that you've seen a curve in the residuals, and then you could leave it there. If you are comfortable with the maths, then you could go that step further and add that in. And also with the idea of interaction. If you are comfortable with looking at interaction, you could look at that between ball type and bounce surface. If you're not comfortable, then you could comment on that from the plot, and I'll just redo that plot and show it to you. So I'll do a scatter plot with colours, and what we were looking at was drop height, and hopefully if you did a bit more investigation, sorry, not drop height, that was our predictor variable, and time to rest. And if I put ball type in here, if you remember this pattern coming out where we had some of the balls bouncing really high and the others not, but also if you look at this carefully, I probably need to make it bigger, and even these dots could do with being a bit bigger. I'll change that to white. So if you look here, for our golf balls in green, some of them are bouncing really high and some of them are not bouncing at all. If you did go and do a bit more investigation and did some more graphs, you'd probably find that this is due to the bounce surface. So the golf balls bouncing on concrete are bouncing really, really high, but the golf balls bouncing on carpet are not moving at all. They just go plop and they sit there. So this different effect for golf ball, depending on which surface it's dropped into, would be an interaction. So we can look at adding both those things in, the curve and the interaction, into a more advanced model. If you're not comfortable adding them in, you could just comment on them and report your basic model. So to add them in, I'm going to go to my general linear model. In my model, I'm going to add in ball type and bounce surface and interaction, and drop height. Is there no squared term there? Might have to come back and look at that separately. I'm switching between programs too much and forgetting how each one does it. We'll just look at the interaction for now. You might need to create a separate column of squared values for the covariate and add that in. I'll do that quickly at the end. If you're not interested, you can just stop watching. So if we add the interaction term in, ball type times bounce surface, the null hypothesis is that there is no interaction, and the alternative is that there is, and we've got very strong evidence against the null hypothesis. The interesting thing here is that the R squared has jumped right up. So if you remember, it was about 50% before. We're only explaining 50% of the variation in time to rest with our basic model. Now that we've added the interaction in, we can explain nearly 94%. Now when you redo a model, your p-values will all change, your R squared will change, but also your residuals will change. So normally you would go through and just plot your residuals again. So I'll put in do a histogram there. So it's changed a little bit. Let's go up to the previous one. So before we had this pattern and all these outliers, now we've got, it's a little bit more even in that it's sort of centered around 0, so it is looking more normal, but it is still quite peaked. And we do have these extreme values, -5 and +5, and this is just the golf balls behaving badly. And we're not going to look into fixing that. You could try some things mathematically to fix this, but that's a little bit too advanced for this case. The other thing you can do if you have this type of pattern coming out in your data is actually to model them separately. Maybe take golf balls out and have a look at a couple of modeling them separately to the rest of the balls. But for the moment we'll leave that. So there are some extreme values, but apart from that it's looking more normal, so that's good. And if we have a look at our other plot, so this time we have the residuals in the y-axis and the predicted values in the x-axis, and they're looking a bit better. We have this funny pattern here for our golf balls, which we know about, and we do still have a hint of a curve here which we haven't adjusted for. So if you're done, if you've had enough, you could stop watching now. If you want to try adding in a squared term, we could do that too. You can do that with me now. So what I'm going to do, because I can't remember if there's an option to add a quadratic term into the general linear model, I'm actually going to create myself a new column of squared terms, which is not that hard to do. So I'm going to have a look at, I'm going to call it height squared, and that's going to be equal to drop height times drop height. That's my squared term. So if you remember back to your high school mathematics, this is where we create a quadratic equation. Adding that squared terms in adds a little bit of a curve. So if you've got any data that looks like it's got a smile or a frown, just a really simple curve, this extra term can help you model that. I'm going to click OK, and I should have an extra column there of height squared. Now there's probably somewhere in SPSS an option just to tick add a squared term in there, but haven't used it in a while, so I'm just going to do it this way. So now in my covariates I've got the drop height, but I'm also going to add in my height squared. I've got to add it into the model. So height squared, main effect, continue, OK. So again, everything changes, all the previous variables are still significant. Our height squared, our curve term, is also significant, so that was a good thing to put in. The R squared hasn't changed much, it's gone up a teeny tiny bit. Probably not going to look at all these parameter estimates, that's a little bit long. But we will have one more quick look at our residuals. So every time we change the model, the residuals are going to change, and we do another quick look. Sorry, histogram. I don't think the histogram will have changed that much because we haven't, yeah, so it's still very peaked. I didn't put the curve on it. We've still got these golf balls behaving badly on either side, but what we're really hoping for, because the reason we added that squared term in was not because of the histogram, it was because of this scatter plot. It was this curve we were trying to take out. So if we redo the residuals versus the errors, so that would be the errors on the y-axis and the predicted values on the x-axis. And it's a little bit better. There's not a huge change there. And we've still got this problem with the golf balls. I would leave the squared term in, even though this is not completely better. It is a little bit less curved to me just looking at it, but it was significant in the model here. So the residuals are still not perfect. The data is still not perfect. We could go more in depth looking at transformations and things to fix this, but as a start, this is a really, this would be a good model to look at this.